Alright, this is lesson 2.5, part 4. I'm going to pause the video and put my data into the calculator. So it says find the best fitting model for the total manufacturing cost. You can look at the data or you can look at the picture. So in this case, first let's get rid of y equals, and then our stat plot's already on, so zoom 9. We can see goes up, kind of has a curve to it, and then it goes back up. So I'm going to go with one arm down, one arm up. I'm looking at cubic. So let's try that one. So stat, calc, cubic is 6. And of course we have to tell it L1, L2, bars, Y, 1, 1, enter. Oh, I've got the wrong thing here. Second, L2. Now we'll enter. So, my R squared is 9.999, so that's very strong. So I'm going to write my equation, y equals A, which is 0.0099, so I'm going to put 0.01 x to the third, plus negative 0.65 x squared, plus 19.2 x plus or minus 0.6. Okay. What does the model predict as the cost to produce 23 forklifts per week? So weekly production, 23, we're going to interpolate, so we can do that with our calculator by finding x equals 23. So I'm going to go here to get there quicker. So x equals 23, y equals 215.8. So the cost to produce 23 forklifts per week is 215.8 in hundreds of dollars. So $215,800. Alright, and then for 35, if we keep on going down, or quickly get there by doing it this way. So 35 forklifts would be 296.65. Or 297, 216. Either way. And was there another one behind there? No. Alright, number 7. Okay, I'm going to pause and put my data in. Okay, so I've got my data in. I got rid of my y equals equation. My plot's already on, so I can just zoom 9. Whoops. Zoom 9. And I can see, kind of looks like a quadratic. Maybe a cubic. We can try a couple and see which one has the higher R squared. So stat, calc, let's try cubic. L1, I'm going to try a couple before I put it into my L2. So this is a 0.997. Let's try quadratic. Stat calc quad. L1, that's not L1. L1, L2. So I think this was 0.997. This one is 0.997. So both of them 0.9973, 0.9974. So I'm going with cubic because it was just a little bit higher here. So I'm going to do it again so that I can get in my vars. I want to be able to use it. So my equation, y equals negative 3.2 x cubed plus 0.2 x squared plus or minus 421.5 x plus 292,132.5. Alright, use the model to estimate the population of Mexico in 1993. So I'm going to use my table, but to get there quicker, I'm going to change this to 1993. So I get to my table, and so the population would be 88.138 in 1993. It says the 1993 information, Please Environment Almanac reports the population of Mexico to be 88.598 million. How close is this to your estimate? So this is in millions of people, so that would be 88,138,000. So how close were we? We were within 500,000, a little less than 500,000. The almanac also reports the growth rate to be between 2.2 and 2.3%. What percentage growth rate does the model represent? What does this tell you about using the exponential model to make predictions? So let's use an exponential model and see what happens. Let's clear that out and do stat calc. This one. So this says, and it's very close in the correlation. So this is 8.6 e to the negative 22. So that would say that A is pretty much 0 and B is 1.2 raised to the x power. Well, if this is 0 times this, that doesn't make sense. So that wouldn't work. I'm going to look into this one a little bit more and see what they mean by this. I'm not real sure. And I will get back to you in class on that one. Make sure to remind me to do number 7D with you. Let's see, is there any more? Oh, yes, seems like it's never ending. 9, 10, 11, 12. Holy cow. Alright, so this will keep going, trudging along. So I guess we are on number, goodness, 8 now. So again, I'm going to pause and put my data in. Alright, so the data is in, and we're going to zoom 9 because we've already got it set up. Definitely looks like a quadratic, so we're going to do stat calc quadreg L1 2 bars, 5 bars, 1. Very high correlation, so write down our equation. 3.7 x squared plus 0.03x minus 0.53. As ticket prices increase, the airline should collect more money. How can it be that when the ticket prices reach a certain amount, profit decreases? Because less people are going to buy tickets the more they cost, so less people, you're going to make less profit. At what ticket price will the airline begin to post negative profit or a net loss? Well, we can look at our table. Let's get us to 450 so we can look from there, because that was the highest ticket price. So let's keep looking, and if we keep looking, it's pretty far up there, huh? We're still at a profit of 2 point something. So now we're getting there somewhere. We're getting closer. 1.5, 1.3, 1.2. Alright, so when ticket prices there it went. So at 661 the profit became negative. So at what ticket price? At $661. Number 9. I'm going to pause and put the data in. So when I looked at the graph, I don't have much time, so when I looked at the graph, it looked exponential to me. So that's why I tried the exponential, and it has a really high R squared, so I think it is relevant. So the model would be 1000.6 times 0.95 raised to the x power. It says, according to the model, what percentage of washing machines can be expected to last 40 years? So hang on just a second. Alright, to quickly wrap this up, I went to 40 on my table. I found 147, so it said 147 customers were still using after 40, and that became 5.2% because of this number right up here.